All right, so today we're going back to scatter plots, and one of the things they want to know is, can you actually use them to get information? So the one thing I want to make sure you understand is that if you just create a graph and you start, let's say you have numbers. If there's no label here telling what that x-axis represents, your graph means nothing. So probably when you are making a scatter plot, some of the most important parts of it are that you label your x-axis, and not just by numbers, but by words. What does it really represent? Okay, we have something here, and we see this is real data. Today we're talking going back to the scatter plots. So it's real data that's scattered around on a plot. What it suggests is, what shape does it make? Is it kind of falling in? Yes.
It's like it's making a line.
Yeah, it's making a line. And so we're going to say that this has a linear trend. Okay? And since notice the data, imagine that the way you read a graph is from left to right. So if you look at my data here, it starts low and it finishes high, right? It starts under 10, and when I finish reading the last point, it finishes at 50. So what we would say is that this trend is increasing. We also would call this a positive correlation, because it's rising. A positive correlation usually exists when one quantity increases, so does the other. As the brain weight increases, so does the lifespan. All right? And then we're going to get deeper into actually writing the line of best fit. So look at the first one. Does it have a linear trend? Yes or no? No. What about B?
Yes.
No. Does it make a line?
Yeah.
Okay, the question is, does it have a linear trend?
Yeah.
Does it make a line, B? It does not. Shh. All right, let's look at C. Okay, it has a linear trend. Would it be a positive or a negative correlation?
Negative.
Good. What about D? No. It's not a linear trend, so we can't say if it has a positive. E. Yes. Positive or negative correlation? Good. And notice F. Is it linear?
Yes.
Yes, it is. But does it have a positive or a negative correlation? Neither. There's no correlation because it starts both high and low at the same time, and it continues. All right, so we're getting into how does this look like in our Common Core book where we're covering scatter plots. So a scatter plot is a graph that shows a relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane. Scatter plots can show trends in data. So how you might see this in your homework, the scatter plot shows the amount of X in grams of sugar and the number of Y calories in smoothies. So without the word sugar and calories, this graph would mean nothing. We can't make sense of it. So when I look at, TJ, you with me? Okay, how many calories in a smoothie that contains 54 grams of sugar? So where do I go to find the sugar? X or Y axis? X. And then I go to right about 56, which is here, and I kind of just follow it up, and what do we get to? How many calories? 270, and we follow it over, yes. Yes. What?
What's up with the corner?
I'm going to explain that. I'm glad you asked. So this right here, David just asked about this corner right here. That's what we call a break. So you'll notice, look at the scale. It increases by how much each time?
10.
Right? 10. And then it goes 240 right here. Do you notice that?
Yeah.
So it goes from 0 to 240. So if I were to make a graph, right? And we were doing, each one was by 10. by the time you finish this graph, if you didn't have that there, your line would be all the way up here. So do you see all that wasted space? So what that break does, it says there is a bunch of other numbers here, but there's no data there. So we're going to skip it. So it's usually you just kind of do this like, it's kind of like a 3. Does that make sense? You go down a little bit. And so then I could start my graph and say, okay, here's, 100. Here's 110. Here's 120. Does that make sense? So I don't have to keep writing every 10, 20, 30, 40, 50, 60, 70, 80. I'm skipping all that portion where the data is not needed in my data set. Yes?
So, like, the homework, are we allowed to use that?
Absolutely. If you have to create a scatter plot. Now, the only thing we might not get to tonight is how to write the equation. You should be able to just graph a scatter plot. If you're given a table, you should be able to make an X and Y axis, break this up, and plot these points. Do you understand? That part you're able to do. The part that you might not be able to do is write the equation. That might take 2 days, and we'll have to finish those problems tomorrow. Do not wait. Do not wait for tomorrow to do all the homework, okay? Do as much as you can today. All right, so then they give us how many grams of sugar are in the smoothie that contains 320 calories. Okay, Ashley?
70 grams.
Right, so this time they give us the output of 320, and I follow it over, and here's my point, and then I go down, and it is 70 calories of sugar. Does that make sense?
How is one that has sugar, like 54 sugar grams, 260 calories, and one that has 54 sugar grams, 290 calories?
Wait, one that has, what did you say?
Why does one that has 54 sugar, like the grams of sugar, is 260 calories and one's 290 calories on the same thing?
They're just taking different drinks or, I don't know. It's real data, so it's not going to be exactly a line. Okay, so we have to remember that. That's good. Okay, and then the last question. What tends to happen to the number of calories as the grams of sugar increases? Annabella. Right, as the sugar increases, the calories increase. And what kind of trend is this?
Linear.
It's a linear, and it's what kind of correlation?
Positive.
Positive. As the sugar increases, so does the calories. Okay. Try the next one, pause the recording, and do the next one on your own. Number 1, how many calories are in a smoothie that contain 51 grams of sugar? Go, Julio.
260.
Right, so I go very close to 50. I go all the way up, and it's about 260. So it's 260 calories. Then they give us an output, how many grams of sugar are in the smoothie that contains 250 calories. And let's go with, is that Cameron? Nope, that's Emily.
The 250 calories is about 52 grams of sugar.
Good. It's in between 50 and 54, so it's about 52 grams. Okay, questions? Yes.
If it's like a trend, how come when there's more sugar, there's some that have less than others?
That's what he just asked. It's not exact date. It's exact data, so it's not going to be exactly lining up like a line, because your store might be a little bit different than yours. So it's just real data. And that's the difference in why it's not exact. Tell whether the data shows positive, negative, or no correlation. How about my age and the number of vehicles owned? Is there a relationship between how old you are and how many cars you've owned?
No. It could be. Like, the older
Not at all.
No.
Not at all.
No.
Just because you're 70 doesn't mean you're going to have more cars than anybody else in the world. Shh. So, As you see, if you look at the graph, if you look at the graph, does it show a correlation? No. Age doesn't cause you, there's no relationship between your age and how many cars you've owned in your life. My husband's older than me. He's owned less cars than me. Yes.
Wait, so is this vehicles that like they own currently or that they have in their life?
Total life.
Oh.
Okay. So, temperature and coat sales. Is there a trend?
Yes.
So, the hotter out it gets, you think people are going to keep buying jackets? No. So, and what kind of a correlation is this? Negative. So, as temperature increases, what happens to coat sales?
Goes down.
So, remember what I said with a negative correlation, as one quantity increases, the other decreases. Yes?
I'm still a little confused on at the beginning, on next to the origin on the graph.
It's called a break. They're just skipping. Notice, this is increasing by fives, right? But the first one increases by 10. So that's just saying I'm not showing those first 20. It's still there, but there's none of my data shows up on the graph over there. So why not just skip it? The break means I'm just skipping those. Yes?
What if it started, what if they were both being negative? What would that, but it was like...
It would be a positive correlation. If
the Y is, say on the second graph.
As something decreases, the other decreases, then it would be a positive correlation. Because it's the same, you're just going from over here. As on...
But this...
Hold on.
Okay.
Right here. As my sugar decreases, so do my calories. You're just going in this direction. This is still a positive correlation.
Can I help?
Yeah, go.
It's like whenever you have -2 divided by negative, so -4 divided by -2, it's going to be 2, right?
For now, I'm going to pause the
Like
recording.
-4 over -2, the slope is going to be 2. So as they increase, the other one